We're now ready to extract the third and final basic type of graphics file from the Traffic Department archive, the BLK files. We'll rely on the same workflow and toolset from the last two segments, but I'll introduce the idea of a default palette. This short video will feel like a review before we change up our approach for the next group of assets. We'll start by copying the BLK files from the game folder to our workspace. Let's take a look at the first file in the hex editor. Now right away we can see some differences between the beginning of this file and the previous file types. True, there's no defined header again, but this time there doesn't appear to be a palette either. We can see several examples of repeating byte triples in the first few hundred bytes, which isn't consistent with palette data. Now as we scroll through the file, we can see possible section breaks, such as here at decimal offset 1024. And again at 2048. Now it's obvious by now that when we take a first look at an unknown file with a hex editor, we're looking for repeating patterns that might give us a hint about the structure. And we can do this by hand with these simple files, but a formal strategy would be to perform a statistical analysis of byte values looking for significant autocorrelations. Now we don't have the tools for that right here, so we'll stick to the manual approach. If we pick this hex value FD on the text side, we can count the number of spaces before it reoccurs in this section. Now it looks like 32 bytes. Now it's not just this particular byte. On the hex side, the entire line repeats 32 bytes later. So does the next line. So if we suggest that one line of an image is 32 bytes wide, then how tall is that image? Well, we've already answered that question. Remember those two section breaks that we noticed at 1024 and 2048? Well, how many 32 byte lines fit into a 1024 byte section? And the answer is 32. 32 squared is 1024. At a width of 32, we can scroll through the file and see much more coherence. Let's go with the theory that this file is packed with 32 by 32 images and no palette data. Now, can we get an idea of how many images are in the file? We'll go to PowerShell and check the size of the file. The first BLK file is 81,920 bytes. If we divide this size by 1024, and we arrive at an even number, 80. Well, we have a theory, but we're not quite ready for programming. This file has no palette, and we can't reuse the same method of mapping byte values to colors if we don't have a palette. The byte values themselves are meaningless without context. Well, remember those PAL files that we mentioned in the asset overview video? Those files contain the default palette data for use with files that don't include an embedded palette for the whole application. We have two palette files to choose from. One goes to the game menus and the other is for everything else. Let's copy the td.pal file to our working directory. Now we're ready for programming again. We need to copy one of the old make files. Let's make the necessary edits. Now we'll open the last source file for comparison on the other side. Then we'll create a new C file for the BLK files. I'll type in the appropriate comment at the top. Copy all the notes since they still apply, as well as the includes and the main prototype. Now, like last time, we can't just reuse the same code or structure because the BLK files are different from the other files we've processed. First, we have to open the two files we're interested in, the BLK file and the palette. I'll separate out the file opening and file calculations this time. Then we need the file size. We'll use the file size to calculate extra metrics. Then we'll go through the surface creation and pointing step. Now we have to pull palette information from the file. We have to process each image in the file. Now for each image, we have to extract the kilobyte data, match it to the palette, and then write to the surface channels. Now we have to change the output extension. And finally, we save the bitmap. Now for the task details. We have to open two files. The first is the BLK file passed as argument 1, and the other is the palette file directly referenced by name. We'll declare those as file pointers. Now we'll find the file size by seeking the end of the file, getting the position, and moving the file position back to the beginning. File size can be large, so we'll reserve 32 bits for it. Now we'll plug the file size metrics for the BLK files. Our guess is that both the image width and height are 32 pixels. With that information, we know the number of images in the file by dividing the file size by the number of pixels. Remember, each pixel uses only 1 byte in all of the graphics we've seen so far. Image dimensions aren't usually larger than several thousand pixels, so we'll reserve 16 bits for these values, and the files we're looking at shouldn't have many images inside, so we'll keep that variable at 8 bits. We can copy the surface creation steps from our old source code with some changes. The surface width for a sprite strip is the number of images times the width of each image. The height of the surface is the height of a single image. We can copy the declarations as well without changes. Now, last time we processed a palette for each image. We can copy that routine, but this only needs to be done once by reading the file. Let's make sure the reference points to the palette file, and we'll close it afterwards. Now declare the current byte iterator as 16 bits. Like before, we need to loop through each image in the file, so we'll copy that iterator without changes. Now for the image extraction, we'll copy the loop from our old file, but there's some changes. We now have explicit dimensions for the images, so we'll use those to define the invariant. We'll also use the image width to define the row and column locations. No change to the declarations. In fact, there's no changes to the rest of the sections, so let's just copy those. I think that does it for programming. Let's go see how this thing breaks. Alright, I seem to have messed up the file saving. No problem. And there we have it. The BLK files contain the tile set for the action sequence. These graphics make up the backgrounds we see as we fly around the map during a mission. So we've now extracted 3 types of graphics assets without much trouble. We'll continue on with graphics in the next video, where we'll use a disassembler to pull important data from the game executable before we program up a solution.